everyone. Welcome to Building Smart Apps with Microsoft Cognitive Services and Xamarin. My name is Boggan, and I'm a program manager at Microsoft working on Xamarin. I've been working for Xamarin since 2012, building Xamarin apps all the way back in 2011. So it's been over 5 years now that I've been building mobile C# applications with Xamarin. And as a PM, a lot of my role is trying out the latest and greatest in mobile development. And naturally, that translates into building mobile apps. So a few mobile apps that I built, Moments, which is just a Snapchat clone built with Xamarin.Forms and Microsoft Azure. So essentially you can send photos to your friends, you can draw on them, you can do all sorts of things, and you can just send them to your friends. It uses Azure Storage to actually store the photos, and Azure mobile apps to actually run the mobile app service. And then on the front end, it uses Xamarin.Forms. I also worked on an application for Microsoft Build called My Driving. And that's an application that we built to track your driving habits and to calculate a driving score using data from your car's OBD reader. So essentially how it worked is your car has an OBD reader, and it's what your mechanic uses when you bring in your car and you're not sure what's wrong with it. He can use it as a diagnostics tool. Well, essentially, you can hook into this using a Wi-Fi or Bluetooth reader. It's just right under your dash. And so we built an application that actually communicates over Wi-Fi or Bluetooth, depending on the platform, and will actually calculate a driving score based off your hard stops and hard acceleration. So if you're doing a lot of accelerating very quickly and stopping very quickly, chances are you're not a great driver. Although I've been living in Boston, and that seems to be the norm. So that uses machine learning to actually calculate a driving score. So that's pretty cool. That uses the traditional Xamarin approach, a lot of mapping logic in that application. And then more recently, I built an app called Smart Coffee. And Smart Coffee uses Azure IoT Hub as well as Microsoft Cognitive Services to actually power a smart coffee maker. So essentially, when I get off the T, which is just a subway in Boston, every morning, I can open up the mobile app, I can say start brewing coffee, and it'll actually send a message off to Azure IoT Hub, which will be sent down to a Raspberry Pi that's hooked up to just a regular coffee maker, and it'll actually begin the brewing process. And the cool thing about this is, obviously, I don't have to be where my coffee maker is to start making coffee. So I have hot coffee when I get into the office every morning, which is really nice. I've also extended this to include lighting. So if I forget to turn off the lights in the office, I can do that from the mobile app as well. And so building mobile apps like this, you can kind of see that mobile development, and you can see this really in consumer applications, has taken a step towards higher user expectations recently. Our phones have lots of sensors and such, so we have a camera, we have a microphone, we have an accelerometer. And users really expect us to utilize all these different sensors when we're building mobile apps. As a mobile developer until very recently, the only thing that I ever considered when I built a mobile app as far as user interaction was touch. I didn't consider maybe using the camera or using the microphone or utilizing the accelerometer, for instance. So considering these different scenarios can really help to meet those user expectations that are just so high right now. And we can actually build some really, really cool applications, whether we're building consumer or enterprise applications. So the main problem with building smarter apps is the whole machine learning, artificial intelligence topic. So far, it's been kind of a topic that's inaccessible to most developers. Personally, I actually took a class when I was at university on artificial intelligence for several hours a week for a whole semester. And when I walked out the other end, it was a good class by a good professor. All I walked away with was a few non-practical algorithms and a little bit of theory. I didn't walk away with anything I could actually use. So it's very difficult to learn, and I had all the resources right there on my university to actually do that, and I couldn't even do it. So even if you know machine learning or artificial intelligence, producing an accurate solution to problems is often difficult. So maybe I have to build something that recognizes text from an image, like an OCR reader or something like that. Well, I might have the knowledge to actually do that, but actually executing that at the scale and at the accuracy that we need may prove difficult for just one person to do. So it becomes very expensive and very prohibitive to actually build smart into your mobile applications and just apps in general. And that's where Microsoft Cognitive Services comes in. So Microsoft Cognitive Services is based on years and years of work from Microsoft Research, which employs over 1,000 scientists and engineers. And so essentially what it does is it takes all this power and complexity in machine learning and artificial intelligence and just boils it down to a few lines of code. So we get all the power of something like facial recognition in just a few lines of code. So you may have heard of Microsoft Cognitive Services before and just not known it. So it was actually formerly called Project Oxford, and it was announced at Build 2015 with just 4 APIs. So as you can see here, we now actually have 22 APIs. Recently this year at Build 2016, even more APIs were added. We're up to 22 APIs now in Microsoft Cognitive Services. And a super generous free tier was also introduced to help you try out Microsoft Cognitive Services with. And you can see the APIs are actually grouped into 5 main categories: vision, speech, language, knowledge, and search. And these really make up a cognitive experience. When we think about, language, it's not only understanding what's said, but understanding the intent. Vision, it's not only about seeing that there's a person right in front of me, it's about recognizing there's a person right in front of me. And so Microsoft Cognitive Services not only, will do the work to actually identify that there's a face in a particular photo, but it'll also do the work to actually identify the person in that photo. So we can create truly cognitive experiences with Microsoft Cognitive Services. So why Microsoft Cognitive Services? Why would I include cognitive services in my mobile apps? Well, there's 3 main reasons that I like to say. First of all, it's easy. All these APIs are just RESTful service calls, so you can call them from anything. There's client SDKs available for the majority of the APIs on NuGet, and they're adding new ones every month. And so it just is really a few lines of code to actually add something like facial recognition into our app. Microsoft Cognitive Services is extremely flexible. Like I said, there's 22 different offerings, and you can combine all of these individual APIs to create a truly cognitive experience. We can use speech to text and then analyze the sentiment of that particular phrase that someone said. Or maybe we could use something like Lewis, which we'll talk about later, to actually understand the intent of something someone said. So you can combine all of these different APIs to create some really cool solutions. Finally, these APIs are tested. Several products at Microsoft are already using the same tech behind these APIs. And there's a regular cadence in terms of release for fixing issues. There's tons of documentation, samples, community support on Stack Overflow. So these are tested APIs. This is not just some side project that someone at Microsoft actually had. This is the result of years and years of research from Microsoft Research, and it's actually using tech that's in production products at Microsoft. So as I mentioned, several products at Microsoft are actually using the same tech. So Bing is going to utilize a lot of the Bing APIs that we're going to cover later in search. Skype and Microsoft Translator take advantage of some of the translation services that are available via Microsoft Cognitive Services. So it's the same tech that's powering these experiences that literally millions of people use, available to us as APIs. So you might say, this all sounds well and great, but I'm not building something that requires me to use facial recognition, and I'm not building this super complex consumer application. Well, that's okay. The great thing about cognitive services is you can do really, really simple things in your app. You can add smart and really simple ways to your app, and you can also do it in much more meaningful, powerful ways as well. So on the simple side, we could even do things like spell check. We could do an adult content check. So I mentioned Moments earlier, the application, the Snapchat clone that I built. Well, wouldn't it be great if I actually did an adult content check on every photo that's sent to another person to actually ensure that it's safe, even if children are using the application? On the complex side, we can do translation. We can understand user intent. We can do facial recognition. And we can even build a recommendation engine for things like our product, just like Amazon.com has when we go to our product page. And I say complex, but it's not really even complex. It's just the actual tech and what's happening behind the scenes is so crazy, but it's actually really, really easy for us to pull these into our API. So depending on the scenario, you can do something fairly simple from spell checking all the way up to something fairly complex. So taking a look at this first category of APIs, vision. So as I mentioned, there's 5 main categories, and within each category, there's individual APIs that combine to make the 22 APIs that are available in Microsoft Cognitive Services today. So the vision group is one of my favorites. The computer vision API is really, really cool. So essentially, it allows us to distill actionable information from images. So if I pass it an image, I can recognize the faces. I can see that there's faces in the photo, so I can see the exact facial rectangles of all the faces in the photo. I can do things like OCR. I can do things like the adult content check. I can even find out if it's a black and white image or clip art image. So there's a lot of really, really cool things we can do with the computer vision API. The facial APIs are some of my favorites in Microsoft Cognitive Services. So the facial APIs essentially allow us to identify people, group them with other people, and even recognize people. So the cool thing is we can train it on a subset of our friends, for example, or maybe employees. So we can train the algorithm around any group of faces that we'd like. But built in, without any training, we can actually identify celebrities and other public figures. So there's some really, really cool stuff that you can do with the facial APIs. The emotion APIs are the ones you've probably seen most often if you've played around with or seen Microsoft Cognitive Services before. And essentially the emotion APIs, given an image and given a face, can actually detect 7 main emotions. So it'll look at that face and it'll detect what percentage of each emotion of the 7 main emotions that you can have. So the 7 main emotions that the emotion APIs expose are happiness, neutrality, sadness, contempt, anger, disgust, fear, and surprise. And these are universal emotions. So whether I'm in China, Mexico, the United States, or in Africa, the facial expressions of someone who's happy are the same, no matter where you are. And these are based off years and years of research as well to actually identify the unique little things that your face does when you're happy. So we can pass in a photo and see how happy someone is, for instance. So there's lots of different applications potentially for the emotion APIs. The video API brings state-of-the-art video processing to us as developers. So essentially, we can do things like stabilization. So imagine the Microsoft Hyperlapse app. I'm sure many of you have heard of it. Essentially, it's one of those applications where you can, leave your phone there for a whole day and you can create these cool time-lapse videos where you can see, the sun rising and things like that, the sun setting. You can do really, really cool stuff like that. Cars driving like you always see at the beginning of movies. So we can do stabilization of that. So essentially in the Microsoft Hyperlapse application, obviously if you're recording a video for a long period of time, it's going to be a little wobbly. And so Cognitive Services actually provides a stabilization API that uses the same tech that the Microsoft Hyperlapse application uses to actually stabilize videos. So that's pretty cool. We can do motion detection. So given maybe a security camera footage or something like that, we can actually detect the exact moment when we see motion. So we don't have to continuously do something like watch a security footage for 3 hours waiting for someone to come into the frame. We can actually do motion detection and find out right when there's motion. And you can combine these with other APIs, as I mentioned earlier. Imagine combining, maybe the motion detection API from the video APIs with the facial APIs. So I can see maybe, for instance, that someone's at the door. I just get a motion event that's happening in my video from my video camera, from my security camera, and I can actually recognize, oh, that's just my mom, or that's just my wife, and I can actually open the door for them. So you can do some really, really cool stuff with the facial APIs. Especially when combined with other things like the video APIs. So the vision grouping as a whole is one of my favorites. So let's look at the computer vision APIs in action. So you can see here we passed in an image of a man swimming. And we're going to get back some actionable information about this image. So first we're going to get stuff about the type of the image. Like I said, we can detect if it's black or white or clip art. We can also detect information about the content of this image. So we get an adult score. So you can see this is only 18.5% adult score. So it's pretty safe. If we get over 50%, we should start getting concerned, but we're only at 18%. So this is a photo that you might otherwise, if passed into another adult content algorithm, might score pretty high because it's a man with his shirt off swimming in the water. But Microsoft Cognitive Services is smart enough to know that this is actually okay, and it only gives it a score of 18.5%. It also identifies the faces in an image. So you can see here that we have the rectangle identified of that particular face, and it's going to give a guess as to the gender and age as well. And we'll also get a category for this image. So you can see we're given the category people swimming, and we're also given a confidence score along with that. Finally, we can identify the image colors in a particular image. So we can see the dominant colors that are presented in a particular image. And you can see the dominant background color here is white. The dominant foreground color is gray. And the accent color is blue from the water. So we're getting a lot of information just from passing it this one image of a man swimming. Let's take a look at the facial APIs. So we can do some really, really cool things with the facial APIs as well. So given this image, it can detect the facial rectangle, just like the computer vision API. And one thing you'll notice with all the Cognitive Services APIs is there's a little overlap between the two, but that's okay. So here we actually detect the rectangle of the face. we'll get some attributes back about that particular face. We can group it with other photos that are from the same person, and we can identify who that person is in the actual photo, assuming that we've trained the algorithm. So we can do some really, really cool things with the facial APIs. OCR, very, very common thing that you'll have to do when building apps these days. And it's great from a user experience perspective because instead of having to do a whole bunch of data entry on something like a receipt, I can just take a photo of it, maybe using something like the Expensify application, and it'll actually upload it. It'll do a smart scan of it, and it'll use OCR to actually detect all the text there and pre-populate all the fields for me because there's so many different fields that I could possibly do. And mobile devices aren't actually, made for massive data entry. So OCR, when you can use it, is a great thing to use. So you can see here we have a picture of a bike with a nice little, with some text that says, "Life is like riding a bicycle. To keep your balance, you must keep moving." And this is just returned as JSON. So you can see here that we're actually just given a language. There's 21 different languages that OCR can work with. It's given an orientation. So even if we pass this text sideways to Microsoft Cognitive Services, it'll actually rotate it along the horizontal axis and get the text for us. And you can see it's divided up into regions and lines, and we can actually get the words on a particular line. So that's really, really cool. So if we're going to be building smart applications, we also need to be smart about how we're building those applications. So Xamarin allows us to build native mobile apps for iOS, Android, and Windows in C#. So I'm showing the traditional approach here. And in the traditional approach, we're going to build our UI natively using all the native controls, all the native paradigms for each particular platform, iOS, Android, and Windows. So on iOS, I'm dropping down into storyboards. On Android, I'm working with XML files, and on Windows, I'm using XAML. That's what comes naturally to each platform because that's how you build UIs on each platform. And we will write all the platform-specific things we need to. So if we have to do speech to text, we can do that as well. We have 100% access to all the APIs we need. And essentially, as long as they're not platform-specific, so as long as I'm not calling something like the speech to text APIs, or I'm not coding up my UI, if it's not platform-specific, we can actually share it across all these platforms. And that's pretty powerful. We can share generally between 50 and 80% of our code using the traditional Xamarin approach, which I'm showing here. So there's no reason those calls to Microsoft Cognitive Services have to be platform specific. They're just RESTful service calls. Same thing with working with a database. Maybe you're using MVVM to structure your application. All that, your models and view models can be shared across iOS, Android, and Windows. And so you're getting massive code sharing. And the result is a native app with native performance. We like to say at Xamarin apps look and feel native because they are native. We have 100% access to all the underlying native APIs, and there's massive code sharing, so we're getting a massive developer productivity benefit. So if you're familiar with Windows development or you're a Windows developer, you know that you can use all the great .NET APIs like system.net, system.link, alongside all the Windows APIs. Well, with Xamarin, the same is true for iOS. So we can take all those great .NET APIs and use them aside things like UIKit, Core Graphics, Core Motion, MapKit. And essentially what we've done is we've C-sharpified the APIs to make them feel more natural to C# developers. So instead of using accessors, mutators, that sort of thing, we're going to use properties, we're going to use events, we're going to use all the things that you would expect as a C# developer. And it's really going to make our applications much cleaner to build. And the great thing with this is there's no sacrifice in actually touching the APIs. We have 100% native API access. The same is true for Android. We have access to all the Android APIs alongside the .NET APIs that we know and love, and the Android APIs written in Java are actually C-sharpified for us. So same thing there, no accessors, no mutators, no weird overrides that you have to do for events. We're using events here because this is C#. So it feels natural as a C# developer to actually use Xamarin. So that really brings us to this. Anything you can do in Objective-C, Swift, or Java can be done in C# in Visual Studio with Xamarin. So many of you have probably heard of Xamarin.Forms, and Xamarin.Forms essentially takes that traditional approach a step further. So it says, why can't we also share a UI layer as well? There's lots of controls and patterns that are consistent across all the platforms. All platforms have a button. All platforms have a text box. So why can't we just write our UI once and have it work on all these different platforms? Well, with Xamarin.Forms, we can do that. So we can write our UI once, and it will run on Windows, iOS, and Android. It's going to be a native application, which is pretty awesome. So it's actually using the native controls. It's not using a web view. It's not using OpenGL or something like that, actually drawing the views. It's using all the native views to actually render your UI. And so the result is, just like I said earlier, 100% native API access, a high performance application because it's a native app, and you're sharing even more code, potentially up to 100%. So the productivity savings here are amazing. In Xamarin.Forms, you might be like, well, that's great for maybe enterprises building forms over data applications or something like that. But what about consumer-facing applications? Well, as I mentioned earlier, I actually built a Snapchat clone using Xamarin.Forms. So you can build some pretty complex applications using Xamarin.Forms. It's not just for simple forms over data apps. So what do I get with Xamarin.Forms? Well, the main thing is you're going to get 40 plus pages, layouts, and controls. And the cool thing, especially if you're a Windows developer, is you can build your UI either in C# or in XAML. So you can reuse those existing XAML skills that you have from Windows when working with Xamarin.Forms. And you can get native mobile apps for iOS and Android as well. So that's pretty cool. We'll get two-way data binding out of the box. We'll get commanding out of the box. So if you're familiar with the MVVM pattern, that's kind of built right into Xamarin.Forms. You don't need to pull in any additional frameworks or anything like that. It's going to work out of the box, which is really, really nice. And we're going to get some other APIs as well, like an animation API, dependency service to actually call into those native APIs, native platform-specific APIs. So we have lots of different things that we can use with Xamarin.Forms. So Xamarin.Forms is much more than just a UI toolkit. It's really a framework for building native mobile applications. So great news, in case you haven't heard, Xamarin is now included in Visual Studio, including the free community edition. So essentially the TLDR on this is if you have an MSDN subscription, you already have Xamarin at no additional charge. So that's very, very exciting. And if you're a guy who builds apps in his spare time at night, then you'd probably fall under the free community edition, or you're a student, or you're an educator, an open source developer. Then you fall under the free community edition and you can use Xamarin for free. So that's really, really exciting. Also of note, the Xamarin SDKs for Xamarin.Forms, Xamarin Android and Xamarin iOS and Mac are now completely open source, so you can go dive into those. If you're a guy who likes to check out, open source projects, you'd like to see how something's done in Xamarin.Forms, you can do that. You can even extend it to do your own stuff. So people have extended Xamarin.Forms to include their own controls and do exactly what they need it to do and just, merge and master. So that's the beauty of open source. So cognitive services, as I mentioned earlier, allows us not only to build exciting, cutting-edge consumer applications, but also enterprise apps. So Xamarin has grown a ton over the past 4 years since I joined the company. So let's build an application, an employee directory application that actually allows me to identify coworkers. Because I know nothing's more awkward than going to a party and someone being like, hey, Pierce, and you having absolutely no idea who that is. So let's build an employee directory app that will allow me to stealthily take a photo of them and actually identify them from the photos in our employee directory. Awesome, so let's hop over to Visual Studio. So you can see here that I've already created our solution, the employee directory solution. But what if you're starting from scratch? You don't know how to create new projects in Xamarin and you want to know how. Well, it's really simple. If you don't already have Xamarin installed, you just need to go to Xamarin.com/download, and that'll give you an installer. Just run that puppy, and just like that, you have Xamarin installed, and you're ready to get started building mobile apps for iOS, Android, and Windows, just like that. And you can see here I'm using Visual Studio and Visual Studio Community Edition to build my applications. Community Edition is awesome because it's free for students, educators, open source projects, as well as small companies and individuals. So if you're building apps in your spare time at night, Community Edition suits you just fine. But Xamarin is included in all editions of Visual Studio, all the way from Community to Enterprise. So if you're a Visual Studio developer, you're going to feel right at home with Xamarin. So you can see here I've just file new just like you would any other application within Visual Studio. And we have some different templates here. So you can see we've added some Android templates, even iPhone, iPad templates, as well as some things like the Apple Watch. So we have templates for Apple Watch, tvOS, and some cool stuff like that. But in this case, I actually just want to build a cross-platform app with Xamarin.Forms. So it can just go into cross-platform, and you can see here there's some different templates for me to select. And generally, I'm going to choose blank XAML app. And that's just going to create a new Xamarin.Forms app that uses a portable class library to share code across iOS, Android, and Windows. And it's going to use XAML to actually define the UI. So all of our views are going to actually be created in XAML. So this is going to feel right at home if you're a Windows developer. So I've gone ahead and already created our employee directory solution. I've added a few things for us. So you can see here that I've gone ahead and added a views folder, a view model folder, and a models folder. And this is to help me implement my MVVM pattern. So what's actually the entry point for a Xamarin.Forms application? Well, it's this app.xaml class. So if we jump into here, we can see right here that we're actually initializing a new application and setting the main page of the application. So this is the first thing that happens when our Xamarin.Forms code executes. And we're actually setting this main page equal to a new navigation page. And the root page of that navigation page is just an employees page. So all these mobile platforms have a concept of push and pop navigation. And so essentially that's what the navigation page gives us. And then we've just defined an employees page. You can see here we've defined it in XAML. This is just a blank page right now, and that's actually where we're going to put our list of employees. In our view models, you can see I've gone ahead and added a base view model. This is just a simple view model that implements iNotify property change. So when something happens in our view model, we want our view to be updated. And so implementing iNotify property change helps us to do that. And then I've created an employees view model here that just inherits from that base view model and sets the title of that view model to employees. If we jump over into models, you can see that I've added an employee model. Just models one of our employees, so that's name, title, and photo URL. Obviously, you may have other properties here as well, but essentially we're abstracting away a particular object. And then I've gone ahead and added a custom control, and so you can see here, here's an example of me defining a control in C# with Xamarin. So this is just a card view cell, as I like to call it. So the card view is really popular in mobile development right now. So I've just defined a cell for us to use. So that's the PCL, but you might be wondering, why do we have all these other platform-specific projects? We have this Android project, iOS, we even have a UWP project here. So why are they here? I thought Xamarin.Forms was supposed to actually take care of all this for me. I wasn't supposed to have to worry about it. Well, that's true. Xamarin.Forms is going to take care of a lot of the stress and worry of having to know all the little details for each particular platform. You're not going to have to know how to use storyboards on iOS, for example. But in case you do, it's there. And Xamarin.Forms apps are native applications. So if we jump down into iOS, for example, and look at app delegate, which is the entry point for an iOS application, you can see that we're actually initializing Xamarin.Forms and loading up that new Xamarin.Forms app. So your Xamarin.Forms app is a native application. Here's an actual iOS project that's running that. And so if we were to write any, platform-specific code, maybe something like speech to text, or we were going to bring in a custom control, maybe like a rating control, we would do that right here. So this is where we can still get 100% access to the native APIs. The same goes for Android. So in our main activity, you can see that we're actually doing the same thing. So we're initializing Xamarin.Forms and loading up a new application. And you can see that it's just going into that app class, and we're actually setting the main page and launching the application. And it's important to note that I'm not having to write any of this code for any of these platform-specific projects. It's generated by the template for us, which is really, really nice. So if you're not writing any platform-specific code, you shouldn't have to make any alterations to those, which is really nice. But it's awesome that we have 100% API access if we need it. So we can look over here, and you can see here that I've gone ahead and added the client SDK for the facial APIs. You can see here this is just a wrapper of the face APIs for Microsoft Cognitive Services. The overwhelming majority of the APIs actually have client SDKs available. And for those that don't, as I mentioned, they're just HTTP calls. They're just RESTful services, so we can just call into that with the HTTP client and use Cognitive Services. So it's super easy to use. A lot of them are already on NuGet, but for those that aren't, you can often find client libraries on the Project Docs for GitHub page. All right, so let's actually get started building our application. So our view model is a representation of our view. So our view model needs to visualize our employees. So first things first, we need to actually, give it some employees to visualize. So let's actually create a new observable collection of that employee type, and we'll call it employees. And so observable collection is really, really nice. So essentially, an observable collection is going to say, okay, if anything is actually added to this collection at runtime, if this collection is modified in any way, update the view. So if I add new employees or I pull the refresh and new employees are added or removed, our view is actually going to update, versus if it was something like a list, it's actually just going to be static because the view doesn't actually know that things have happened. So observable collection is a great class that we can use to actually notify our UI that things have changed. So it's just like a list. It's just list on steroids. And then I've gone ahead and added some sample data for us, so we don't have to go ahead and type that out. And you can see here I'm just spinning up some new employee objects and adding them to that observable collection. So let's jump over to our view. So this is our employees page. And you can see here we have a content page, which is just the page that you're probably going to be working with the most in Xamarin.Forms. So the content page is essentially a page where all of your controls are going to be added. So you're going to have a lot of navigation-based pages in Xamarin.Forms. There's 7 main pages. But you're also going to have pages where you're just going to want to put stuff. And content page is that type of page. So you're going to be working with content page a lot. And so within a content page, we need a way to actually lay out our controls. And we can do that with something called a stack layout. And so a stack layout, if you're familiar with Windows development, it's just like a stack panel. It's going to lay things out either horizontally or vertically in ordinance with the way that they're actually added to the stack layout. So if I add a button first and then a text box and the orientation of my stack layout is vertical, well then whatever control is listed first is actually going to display on top of the other. Okay, so we want to actually add a list view to visualize this observable collection that we defined in our view model. So first things first, let's actually add a list view. And we need to go ahead and add the item source property. And the item source property is just a property that's going to define, hey, where is all the data for this list view coming from? And so in this particular case, it's coming from employees. Well, how does my page know that it's actually, where does it find this employee's object? It's obviously in here, and I know that, but how does it sort it out? Well, actually, in our code behind, we have to set what's called a binding context. And in Windows, I believe this is called a data context. And you're just going to set this binding context equal to our new employees view model. And I believe we're going to have to bring in the view model's namespace. Cool. And so essentially, whenever we're doing data binding, it's going to look in that binding source to actually find that. So it's going to find this employees observable collection. That's awesome. Okay, so let's jump back over to our view. So we define the item source. We also can specify some cool properties. So I can say has uneven rows. In this particular case, the card view cells can render on different sizes, so we'll say yeah. And then we can set things like the separator visibility in between the cells. And in this particular case, I'm going to say none. And you can see here we've added our list view. And so now that we have defined how our list is going to work at the macro level, we need to actually define it on a cell or row level. So we can do that by setting the item template for the list view. You can see here I added some duplicate XAML, little typo. And we'll add a data template. And so we can bring in that local control. So we have several cells built into Xamarin.Forms by default: image cell, switch cell, text cell. And those are often going to be sufficient for you. But you can also build your own. And so in this case, we're bringing in a local control that we've created called card view cell. And we'll set the text property equal to binding name. We'll set the detail property equal to binding title. And we'll set the image source property equal to binding photo URL. And so several cool things are actually happening here. So Xamarin.Forms is smart enough to know if we're binding to employees at the list view level, then our each cell is going to have an employee. And so we can bind directly to the name property of that employee, the title property, and the photo URL. And Xamarin.Forms is also cool in that it's actually going to cache this photo for us for a specified period of time. So this could be a local image, this could be a remote image. In the event that it's pulling down something over the internet, in which case it is for this app, it's actually going to cache it for us, which is really, really nice. Okay, so let's take a look at this in action. So I'm actually going to build this using the Visual Studio Android emulators. And the Visual Studio Android emulators are great because they work really, really well alongside Hyper-V. So if you're doing Windows 10 mobile development, the Visual Studio emulators are going to work great. And they're lightning fast. I don't know if any of you have ever done Android development without them, but they're very, very fast, and it's going to definitely help your workflow, speed up your workflow quite a bit. And so we're going to go ahead and build this for Android and take a look at what this looks like. And so you can see here we've got a little card view, and we've added some employees. So that's exactly what we wanted to do. This looks really, really good. So let's take a look at what it actually looks like on iOS. So we can just change the startup project over here to iOS. And I'm going to want to deploy to the iPhone simulator. And you can see here I'm given a number of different options, whatever I have installed on my Mac machine. So with Xamarin, we can actually build iOS applications from Visual Studio. We're going to need a Mac still because that's where our actual build process takes place. But once we have that Mac, we can actually, not even have to know it's there. After Xamarin Evolve 2016, which is our developer conference that we had this year, we announced something cool called iOS Simulator Remoting. And so essentially what that means is I don't ever have to be able to see what's on my Mac, because we can actually remote the iOS simulator from your Mac machine, whether that's a Mac Mini in your closet somewhere or in your desk drawer. We can actually remote the iOS simulator to your Windows machine. So it's a very seamless experience. And you'll find it's quite interesting because you'll actually be able to do things with the iOS remoted simulator on Windows that you can't even do on iOS. So we can actually interact with the iOS simulator that's remoted to Windows with touch. That's something we can't do on Macs because Macs don't have touch displays. So I can't interact with the iOS simulator using that, but with the iOS remoted simulator I can. And so you can see here, this is our iOS simulator, it's deploying, and we actually have the same app, the same code is running here on iOS that was running on Android. And you can see this looks like an iOS application because it is an iOS application, it's an iOS native application. So that's pretty cool. So that's Android enough, so we're on a good track. But we actually need to use Microsoft Cognitive Services to build the smart into our app. So we built an app, which is awesome, that runs on iOS, Android, and Windows. But let's actually build some smart into our app. So first things first, let's jump over to our employee directory employees view model. And let's add a new method for registering employees with Microsoft Cognitive Services. So we'll add a new method called register employees. And so essentially what we need to do when we're using Microsoft Cognitive Services facial APIs is we need to first create a thing called a person group. And this is just like a folder of people. So within a person group, we'll add people. So in this case, that's employees. And then we'll add faces for those particular employees. And we can add multiple faces to the same person. And that's actually going to make the algorithm, obviously be able to identify the person better than if they just had one photo. But the brilliance of the API is that it actually only works with just one photo. And then we'll train the person group. So at a high level, that was create a person group, add a person to the person group, add a face to that person, and then actually train that person group. That's going to use the algorithm to train Microsoft Cognitive Services to actually identify a face if it was given one. So how do we go about doing this? Well, first things first, let's actually create a new class level field called person group ID. And this is just an identifier that we're going to use for our person group that we'll need later, and that's why we're storing it at the class level. So we'll go ahead and set that person group ID equal to just a new GUID. And now that we have that person group ID, let's actually use the facial APIs from Microsoft Cognitive Services. So we'll want to bring in the namespace for that. And so we brought in the facial namespaces, that's awesome. And so let's actually create a client. So we'll create a new face service client. And we need to actually get the subscription key, which I believe is an app. I can grab it from over here. And you can actually generate this key, completely for free via the Microsoft Cognitive Services website. And it's provisioned on a per API basis. So it's not just one key for all the APIs. Each API has its own key that you get. Okay, awesome. So we have our client. Let me actually bump up the text size on this puppy. So we have our client. So now we're ready to interact with the APIs. So let's actually go ahead, and these are all async await compatible. So we're going to want to await this puppy. And let's actually create a person group. And so you can see here we just need to pass in a person group ID, which we just created, and we'll pass in a name, pass in Xamarin employees, and we can pass in some optional user data as well, but we're good in this case. So we have our person group. So let's actually add employees and their faces to this person group. So we can just loop over that employees observable collection that we created. So we go in here, let's just create a person. So we'll create person async, and you can see here we have to pass in that person group ID and then a name for that person. So in this case, that's going to be employee.name. We can pass in some additional data, but we don't need to. So now that we have that person, let's actually add that person's face. So you can see here, we have to add the person group ID, the person ID, and this is the reason I created a local variable P. We'll get that person ID, and then an image URL. So that's just employee.photo URL. And then again, we can pass in some optional user data. Okay, awesome. So now we've actually created our person group, added people to it, and added their faces to that particular person. So let's actually train the algorithm. Sounds very complicated, but we can do it in one line of code. So we can train person group async, and then we'll just pass in the person group ID. Awesome, and this is actually going to do the work of training, of using all these faces and identifying all the unique features within them and actually training our person group. And so this is actually something you might be doing on the server. Maybe when you provision a new employee, you just go ahead and add that person to your existing person group. You add a person face to that existing person that you just created, and then you go ahead and retrain the algorithm. This may not be something that you're actually doing in the mobile app. We'll actually do the identification bits in just a second. The registration is something you certainly can do in a mobile app, but you may be doing, and maybe like an Azure app service, for example. And so let's go ahead and make sure that that's called when we're actually spinning up this employees view model. Awesome. So now let's actually add a command to actually identify employees. So we can actually, we can actually add a command, which is just how our view model and view respond to events. So if data binding is how the view model and view pass data back and forth between each other, commanding is how it works with events. So we'll go ahead and bring in Xamarin.Forms because they have a command implementation for us that we can use. And you can see here I've just created a backing field for our command, find similar face command. And if our find similar face command is null, then let's go ahead and spin up a new command. And when our new command is called, let's actually execute this code. And I'm going to go ahead and resolve this namespace. And so this is just using plugins for Xamarin, which are just neat little things that actually abstract platform-specific functionality into something we can use from shared code. So in this particular instance, I'm using acr.userDialogues, which allows us to present dialogues to the user from shared code. Okay, so now that we have our find similar face command scaffolding added, let's actually go about taking a photo, number one, and then actually passing that to cognitive services. So I mentioned plugins for Xamarin. There's also an awesome plugin called the Media plugin. And the Media plugin is awesome because it allows us to actually take or select photos from shared code. So each platform has its own implementation of how it handles camera stuff. But in this particular instance, we can use the Media plugin to actually take photos for us in cross-platform code, which is really, really awesome. Okay, so first things first, we're going to actually initialize our Media plugin. So we'll just .initialize, and I believe that's an asynchronous method, so we have to await it. And then we'll actually create a media file. And this is just an abstraction of a media file for each platform. And we'll call it photo. And first things first, we need to actually make sure that we can take a photo on that platform. Believe it or not, there are some platforms, some of the Android phones, that don't actually have cameras built into the phones. So if the camera's available, we can take a photo. So we can just set photo equal to cross media, current, take photo async. And you can see here we have to pass in some store media camera options. And we need to set a directory, and we'll just call this Xamarin employees. And we have to set, I believe, a name, and we'll call that employee photo.jpg. Awesome. So now that we have our photo, we have our directory, we're good to go, right? Well, no, we have to define that case where the camera is not available. Well, that's awesome as well. We can select photos using the media plugin from the user's media library. So we can just pick photo async. Awesome. So now that we have the photo, let's pass it to cognitive services and identify who's in the photo. So let's actually just wrap this in a using, because we're actually going to be converting our photo into a stream. And this is an iDisposable object. We don't have a memory link, so we need to wrap it in a using. So let's actually just get the stream for that photo. Awesome. So now that we have a stream of the photo, let's actually pass that to cognitive services. So we can go ahead and recreate the client. So I'll just copy this. And if I was a good developer, I would have just made this class level. That's okay. So we've created our client. So let's actually detect all the faces in a particular photo. So first, before we identify them, we have to know that there's faces in there. So we can grab that. So we can just call detect async, and as you can see, we can pass in an image stream here. So we'll just pass in stream. And that's going to identify all those facial rectangles and faces in the actual photo. And next we need to get the facial IDs from this that we can use to identify actual users. So we can just do faces.select, and that's going to give us an array of all the face IDs in there. Awesome. And so now let's actually identify the person. And all we have to do is pass in that person group ID, our face IDs, and this is going to pass us back the result. Oops, face IDs. So this is going to pass us back the result. So if there's multiple people in the photo, it's actually going to identify them. In this particular instance, we're going to assume that there's only one person who's in the photo. So we'll just go ahead and grab the first result in results, and we want to grab the first candidate, which is the most likely candidate. There is a probability score associated, a confidence score. We'll just grab the first candidate, and we'll grab the person ID. Okay, so now that we have the person ID, we can just use that to actually look up the person. So if our person is equal to await client dot get person async, and we can pass in that person group ID, and as well as the result. And this is actually going to identify who it is. So then let's actually just pop up a dialog that's going to show who it is. So we'll just go user dialogs.instance.show success, and we'll use this a little C#6 here, and we'll say person identified as, and we'll identify them as person.name. Awesome. So now we're ready to actually identify some people. And the actual code for identifying someone here, you can see from line 86 to 96, 10 lines of code. And if you want to include all the code up here for actually registering employees, that's from 39 to 53. So in less than 30 lines of code, we can actually do facial recognition. That's pretty awesome. So let's actually go ahead and build this for iOS. And you can see here that our app has launched, and we have the identify button here as specified in our content page toolbar items. So we'll go ahead and click that. But first, you're probably like, okay, I know who this guy is. I know who that guy is. Probably know who this guy is. I know who this guy is. But who is this guy? Who's this Pierce Boggan fella? I have absolutely no idea who that guy is. So let's actually see if that's him over there. So we'll go ahead and click identify. And if you remember, we're actually using the iOS simulator, and that doesn't have support for using the camera. Well, because our code handles that, because the media plugin allows us to select photos, we can actually do that. So maybe I snapped this photo earlier at the party, and let's actually see who that was. So I'll click on a photo of me, and it's actually going to pass that up to Cognitive Services, and you can see that the person was identified as Pierce Boggan. So that's really, really cool. In 30 lines of code, we just use Microsoft Cognitive Services to build a smart employee directory app with Xamarin. So that's awesome. That's really, really cool. Go ahead and stop debugging. Jump back over to our PowerPoint. Awesome. So that was a look at the facial APIs that were in the vision group. But what about speech? Speech is a very common thing when we think about cognitive function. Speech makes sense. So the speech algorithms from Microsoft Cognitive Services allow us access to state-of-the-art speech powered by Bing. So we can add search-driven actions to our apps. So there's three main APIs in the speech grouping. There's the Bing Speech API, which allows us to do speech to text, super common thing in mobile apps. Understand intent, really, really cool. Perform speaker recognition with the speaker recognition API. So just like facial recognition, but for speech. So given a sound bite, we can identify who this is. And we can even use something called the Custom Recognition Intelligence Service, or CRIS. So imagine we're building an application where people are going to be saying the word namespace or PCL. Well, obviously the cognitive services model is not going to be trained on these sort of languages. And maybe we work in a very domain specific industry where there's going to be some weird words that you wouldn't expect people to say. Well, we can actually use Chris to train our model so that it actually understands things like namespace or PCL, which is really, really cool. So taking a look at speaker recognition, it's very similar to the facial APIs, as I just mentioned. Essentially, we need to enroll a voice print, just as we kind of enrolled a person and we added a person face to that person. We just need to enroll a voice print. And then from that voice print, we can actually use that to recognize or verify a particular user. So given a grouping of people, we can actually identify, given a voice clip, who is speaking. Or we can say, yes, this person speaking in this clip is also the same person speaking in this clip. So verification. So that's really, really cool. And that's in the speaker recognition APIs. So once we're dealing with speech, the next obvious step is language. And this is one of the coolest ones. We can build some really powerful applications using the language APIs for Microsoft Cognitive Services. So first up is the Bing Spell Check API, which essentially allows us to detect spelling errors and provide accurate suggestions based off those errors. And it's actually trained using billions of web pages. So it's got lots and lots of data. It's already trained, and it works with tons of different things we're about to see. There's a web language model API, which is actually going to index the web to calculate probabilities of natural language expressions and suggest the next word or phrase. So on iOS 9, for example, and they've had this on other phones for a while, you can actually be texting a friend and it'll suggest the next word that you're going to say. Well, you could use the web language model API to actually do that with Microsoft Cognitive Services. The linguistic analysis API allows us to identify nouns, verbs, etc. in text, and it's also useful later for identifying sentiment. The Language Understanding Intelligence Service, or LUIS, allows us to build a model that understands natural language. So say I'm building an app for a smart home, and my user says, turn down the thermostat in the living room. Well, you can use LUIS to actually identify the action, which is to turn down. You can identify the target of that command, which is the thermostat, and you can identify the location, which is the living room. And from that, you can actually, take action within your application using something like LUIS. So understanding user intent. We can quite literally build a Cortana or Siri clone using these APIs. So it's really powerful. That's available to us in just a few lines of code. And finally, we can use the text analytics API to detect sentiment. So a cool little use for this that I was thinking of was if you're building an application where you have users rate something, maybe you pre-populate the rating control 1 through 5 depending on the actual sentiment detected from their review. So I know sometimes people mean to be very positive, but what they end up doing is either being very neutral or very negative in a review. And so we can actually let them know as they type by updating that control. So there's some really, really cool things you can do in mobile apps with sentiment. So taking a look at the spell check APIs, you can see here's some common misspellings. And you can do some really cool things. So it can check a single word. So it can, as you can see here, it can change the number 4 to 4. It can look at proper nouns. So Microsoft, it obviously knows that needs to be capitalized, and it's obviously one word. There's a misspelling here. Same thing with names. And it can even do hipster startup names like Lyft. It knows that it's not supposed to be L-I-F-T. You meant L-Y-F-T. So it's really smart in terms of that. It's not just going to, give a suggestion based off something it thinks. It's actually going to use, cognitive understanding to suggest something based off the context of this sentence. And so as you can see here on the right-hand side, we can actually identify the error and we can get a suggestion based off of that. So that's really powerful. I mentioned LUIS. You can understand quite literally what your users are saying. You can build these recognition models, and you can build a Bing or Cortana mini clone into your application. So if your application is particularly built towards something that would be good for voice commands, then LUIS is definitely something you should look at as a developer. So here's an example of a language understanding model in action. So say I say news about flight delays. Okay, well, it's going to identify the entity as flight delays. And what might my intent be based off of that? Well, I said news about flight delays, so it's probably going to be to find news. And so I can see here that I'm also given a confidence score. In this case, it's 99.8% confident that I want to find news about flight delays. So that's really cool. So within my application, I can then display news about flight delays. So based off the intent, we can actually do something within the application. So the models are actually really, really easy to work with. You would think you would get something very complicated back, but all we're getting back here is an entity and then an actual intent, and then the probability that that intent is actually the case. So search is not really something we necessarily think of as a cognitive function, but at the same time it kind of is. We're always looking in our brain for figuring out, looking for things, that sort of thing. But search kind of takes it to the next level, the search APIs from cognitive services, and allows us to search the entire web. So there's all these different APIs. There's 5 different search APIs. And they can be wrapped up in several different ways. The Bing search web search API is essentially like searching on Bing or Google.com. So you're going to get a combination of all the different search verticals. So you're going to get images, video, news, just like you would on an actual web page. And so maybe I'm searching for presidential coverage for the US elections this November. Well, it's going to probably show news first, maybe video second, and images third. It's going to be smart enough to actually rank the content from the different mediums, just as you would see if you went to Bing or Google.com. So Bing web search API is really, really cool. The Bing Auto Suggest API is also great. We can add intelligent auto suggest options for searches. So maybe I'm building an application where users are typing in the names of a sports team to add as a favorite. Well, if I start typing in Boston, obviously I can add the Boston Red Sox, but maybe I meant to type in the New England Patriots. But if I'm using just letter-to-letter matching, it's not going to show up. So we can use something like the Bing Auto Suggest API to actually provide intelligent solutions. Another thing also worth looking at if you're trying to power intelligent search is the Azure Search Service. It's amazing. My colleague Mike James has done a ton around that, and you can build some pretty awesome experiences even with something just like the Bing Auto Suggest API. And then, as I mentioned earlier, you have the Bing Image Search, the Bing Video, and the Bing News API. These are just the individual verticals that are available via the Bing Web Search API. So cool things about this, Bing News Search. I can literally build a Flipboard clone using this. Give a topic. So I care about the presidential elections. I care about politics. And it's actually going to source news for me based off that topic and add it to my application. So it's quite literally you could build a Flipboard clone with just this API. So really, really cool stuff. That's a common theme with the Microsoft Cognitive Services APIs. I can take one of these APIs and quite literally build a clone of another product, another popular product with it. The knowledge APIs are what I think are the coolest of the entire subset. I know I say that for every grouping of the APIs, but this is true because the knowledge ones is always something that I've always found interesting, but I haven't quite had the cognitive skill to understand. So there's several different APIs available within the knowledge grouping. So we have the academic knowledge API, so we can look up stuff from research papers, conferences, journals, that sort of thing. So that's really useful for academic functions. We can do things like add interactive search over structured data to our project with the knowledge exploration service. We can do entity linking with the entity linking service. So imagine I'm given a grouping of text from a textbook. I can use the entity linking service to actually identify all the entities in that and grab summaries from Wikipedia, for instance, on the grouping of text. So you could grab more context for users as they read. So you can do some really cool things with entity linking. But my favorite of this grouping is the recommendations API. So essentially, we can add item to item or user recommendations right into our application with just a few lines of code. And this is a topic that's completely inaccessible to me as an everyday mobile app developer. I don't know how to build machine learning models and work with big data. But the recommendations API boils it down into something really simple for me. So I can do something like if I go to Amazon.com and I search for something, you can notice that there's also commonly bought with, and I'm going to get some other suggestions, and oftentimes that drives new purchases. And if you're building an e-commerce solution, this is obviously something that's extremely important. So we can add recommendations with the recommendations API. We can even add user recommendations. So if we find that I'm buying lots of Xbox games, which I tend to do, it may hone in on a particular type of Xbox game I like to buy. Maybe I'm buying a lot of sports games, and then it can actually recommend that I buy another sports game based off my past predictions, or my past purchases. So we can do some really cool stuff with the recommendations API. So let's actually take a look at the recommendations API in action. So we're going to build an application that uses data from the Microsoft Store, so the Microsoft Online Store, to actually identify what video games and what video game accessories will go well with products that I select from the store. And this is using real sample data generated from the Microsoft Store. So let's take a look at building that, and we can add item-to-item recommendations to our app in just a few lines of code. Awesome. So let's take a look at actually adding recommendations to our Microsoft Store application. So if we jump over to Visual Studio, you can see that I've gone ahead and created a new Microsoft Store Xamarin.Forms application. Let's go ahead and build that and take a look at what it actually looks like and what modifications we're going to make with the Recommendations API that could literally bring our business lots of new revenue just by providing intelligent user recommendations at checkout. So essentially all this is just a list view that shows our catalog, and you can click on a particular item in the list view and see the details on it, add it to the cart, and then the idea is at cart time, we'll actually get recommendations. So of course everyone loves Titanfall, so we'll add that to my cart. And if we jump over here, you can see that's in my cart. And we also have a you might also like section. This is where we're going to want to provide our recommendations. So let's go ahead and write some code to actually do that for us. So first things first, the Recommendations API requires a little bit of upfront work that's not required on some of the other Microsoft Cognitive Services APIs. So there wasn't much, as I like to call, pre-work that went into using facial recognition, for example. We just kind of did it. With the recommendations, it's a little bit different because, of course, we're using big data to calculate these recommendations. Sounds very scary. I always thought machine learning, as I mentioned earlier, was a little bit of a scary topic. All the idea of creating your own model and that sort of thing was very overwhelming to me. But it's actually really easy to use the recommendations model. And if you're building an e-commerce app, you'll find that you actually already have most of the data that's required. So first things first, we need to actually create a model. Sounds complicated. All is creating a name for your model. So in this case, it may be like Microsoft Store model. Number two, we need to create a catalog. So that's essentially a listing of all the items in our store we want to provide recommendations for. And we need to do this in CSV format. So you can see here, this is just an ID, the item name, and then the category. So this is super standard stuff. If you're building an e-commerce app, you're going to have this data already in a table. You just need to export it as a CSV. Next, we need to actually have a usage file. And this is how the recommendations are actually generated. So first things first, we need a user ID, an item ID, and then a timestamp for that actual transaction. And then once we have a catalog, a usage file, and a model, we'll actually build that recommendation model. And it sounds very scary, but it's essentially just passing information along to the Recommendations API. So we're just uploading that catalog, we're uploading that usage file, and then we're actually generating a recommendation model based off that usage. So say in a month we have new usage data and a lot of people have been downloading a new item. Well, our recommendations are going to be updated to reflect that if we use a new build. So the cool thing is we can continue to use the same catalog and we can add new usage files to get even better recommendations. So the other cool thing with recommendations is you can potentially use it for things outside of e-commerce. So imagine for my catalog, instead of items, I had people, and people were my product. So we had people as the catalog, and we also had people in the usage file. So instead of user ID, item ID, timestamp, we might have user ID, timestamp. And so in this particular instance, we may be able to generate friend suggestions, for instance, using something like the Recommendations API. So that's really cool stuff. And in a lot of instances, recommendations can make or break an application. If Amazon didn't recommend items to me to buy, then I may be less likely to buy things on their website. So for many businesses, recommendations are the lifeblood of their app. And so it's pretty cool that Microsoft Cognitive Services makes it so simple. So let's actually look at how simple it is to consume a particular build from our application. So we're going to look at in particular at the checkout view model. And you can see here I've added some constants. The build ID, which as I said is just a combo of that catalog file and usage file that's been uploaded and recommendations have been calculated by Cognitive Services. Again, sounds very complicated. It's just a matter of uploading CSV files. Our model ID, so this was the name I selected, just a GUID. And then an account key generated from the Cognitive Services website, and then just a URI endpoint we're going to hit. And you can see here we have a cart and the recommendations object. So let's actually create a new method called generate recommendations. And in this method, first things first, we need to new up a client, new recommendations client. So new recommendations API, we need to pass in our account key and our base URI. Pretty standard stuff when you create a client. Next, we actually just need to get recommendations. So we'll just await client.getRecommendations async, and we'll actually pass in our model ID, our build ID, the item ID. So we can actually pass in multiple items in our cart if we wanted to. In this case, we're just going to pass in the first item in our cart's item ID. And we'll pass in 3 results back. So 3 recommendations to the user. We don't want to overwhelm them. And so next, let's just loop through those recommendations and add them to our UI. So we can loop through the recommended item set info property. And then within that, we can loop through the actual items in a particular recommendation. And so all we have to do now is actually add it to our UI. So in that recommendations observable collection, let's add a new inventory. And we'll go ahead and add a name for that. And in this particular instance, that's just going to be rec.name. So that's just the name of our particular item. And then we can add a probability. We probably wouldn't display this to the user, but for our debugging purposes, we'll go ahead and do that. So for the description, we'll actually use recommendation.rating.toString. And this is just a probability value associated with a particular recommendation from 0 to 1. Awesome. And so finally, we just need to call generate recommendations, and we're good to go. So let's actually go ahead and build this for Android. And we'll see just how easy it is to add recommendations to our app. We're 32 through 47, so 15 lines of code. Most of this is, braces, half of it's braces. I really could have written it in less code, and we've got recommendations in our application. I don't have to know anything about how machine learning works, how artificial intelligence works. All I have to do is provide it with some data. So that's very useful. So let's actually see this in action. So of course, as I said earlier, naturally going to add Titanfall to my cart. We'll come back over here to the cart, and it's going to take a second for our recommendations to load from our web service. So our UI is going to go ahead and load up, but we need to give it a second to actually load the recommendations. And you can see here that we were actually given 3 recommendations. So Ubisoft Fighter within Xbox One, EA Madden NFL 25 Xbox One, and Konami Metal Gear Solid 5 Ground Zeroes for Xbox One. So if I'm likely to buy Titanfall, these are 3 other titles I'm also likely to buy. And so I may have guessed number 1 and 3, but number 2 is a little bit surprising. So that's a cool recommendation that I'm providing to my user, and I may say, hey, you can add this as well. This may be a game you're interested in. And maybe I provide them with a discount or something like that. But this is a cool little thing you can build into your mobile app that obviously, if you're building something e-commerce related, can be huge in terms of revenue. And it's just a few lines of code. So that's really, really cool. Awesome. So obviously, there's a lot of cool stuff we can do with cognitive services and apps we're already building. But if you've been watching this entire webinar, you see that there's great potential for doing literally world-changing things with Microsoft Cognitive Services. And so let's actually take a look at an app that was introduced at Build, where Microsoft Cognitive Services is quite literally changing the world.
I'm Saqib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind, and that's where I was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives, and one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response and you think, is everyone listening really well or are they half asleep? And you never know.
I see two faces, 40-year-old man with a beard looking surprised, 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do, but artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
Awesome video. So that's an example of obviously some of the world-changing things we can do with cognitive services. So there's some great silly things we can do with cognitive services as well. So there's some great showcase applications available that are built with cognitive services. So many of you may have heard of howell.net, where you can pass in a photo of yourself and it'll provide an age estimate. And sometimes those are extremely flattering, and other times you feel terrible about yourself after using the app. But still a really cool application. The Mimicker alarm, my favorite one. Essentially, I'm really bad about getting up in the morning, and I have to match a facial expression using the emotion APIs in order for the alarm to cut off. And then Fetch is a pretty cool example of using Microsoft Cognitive Services. It'll actually identify, given a photo, what type of dog is in that photo. Well, what actually happened was over 70% of photos uploaded to Fetch were selfies. And so now what it actually does is it identifies what dog you'd be given a selfie of yourself. So it's funny how sometimes the users can define exactly what the application is, even if that's not what it's meant to be. So some really cool showcase apps that are worth checking out. You can get started with Microsoft Cognitive Services completely for free at Microsoft.com/cognitive. As I mentioned, all these APIs are provisioned on a per API basis. So I'm using a ton of the facial APIs. I don't have to be concerned about using maybe the vision APIs or something like that. They're all individually provisioned, and there's a super generous free tier. So there's no reason not to get started today at Microsoft.com/cognitive. You can get started today with Xamarin at Xamarin.com. As I mentioned, available in all editions of Visual Studio, from Visual Studio Community Edition, which is free all the way up through Enterprise. A lot of people always ask me when I'm giving talks and when I'm talking to our awesome community, where do I get started? And that's always a tough question to answer until recently. So we actually have Xamarin University, which is live, unlimited mobile development training from anywhere in the world. So there's over 70 different courses you can take, and essentially you can get scaled up from knowing absolutely nothing about mobile development to being an expert in just a matter of a few months, which is pretty amazing. So it's not just one platform, but you can learn iOS and Android. You can learn how to cache data. You can learn very advanced techniques as well. So there's some awesome things you can do with Xamarin University. If you're looking for free ways to get started and learn about mobile development, Xamarin University offers free self-guided learning. So essentially, of the certification track for Xamarin University, you can access 7 of those classes from a self-guided learning perspective. So you can go through 7 of the modules, and that's going to build a groundwork for building iOS and Android applications with Xamarin. And so essentially, once you get that groundwork, I found that it's very easy to move forward from there and actually jump into the world of building mobile development. It's sometimes hard just to know what's important. There's also 5 pre-recorded classes from Xamarin University via Visual Studio Dev Essentials, so that's worth checking out. And Xamarin University also has an awesome free trial, as well as guest lectures and lightning lectures that are available to anyone. So definitely worth checking out. Great resource for getting started with mobile development. So with that, thank you guys. The slides and code are available at Pierce Boggan on GitHub. So github.com/Pierce Boggan/smarter-apps. Obviously, if you have any questions about cognitive services, you can ask them here now. But if you don't think about it right now, you can always ask me later at Pierce Boggan on Twitter. That's always a great place to follow me and find updates about the latest and specifically Microsoft Cognitive Services, but Xamarin in general. And so with that, thank you guys so much. I'd love to take your questions.